A man parks his quad bike of mass 350 kilograms on a slope inclined at 30 degrees to the horizontal, as shown in the diagram. The coefficient for static friction between the wheels of and the slope is 0,7. Calculate the maximum frictional force acting on the quad bike. So the first thing we're going to do is we're going to draw our diagram where we've got weight acting down, and if it's weight, it's 350 multiplied by 9,8, and you land up with an answer of 3,430 newtons downwards. That has two components. It has a downward component that is perpendicular to the slope, and the angle over here is 30 degrees, and it has a component down the slope parallel to the slope. We are expected to calculate the maximum frictional force acting on the quad bike. So in other words, we would like this force that is acting up the slope. Before we can work out friction, we first need to work out the normal. So let's do that. We can close up this triangle over here. There's my 90 degrees, and I land up with a adjacent, I'm trying to find this normal over here. Well, it will be a value that's equal to the normal, but this line over here, so that is adjacent. So I'm going to say my force normal is cos 30 degrees is equal to adjacent over hypotenuse. And I find that my normal force is therefore equal to 2,940,47 newtons. If I now want to get my frictional force is equal to the coefficient of static friction multiplied by the normal force, so that's 0,7 multiplied by 2,970,47, and it becomes 2079,33 newtons up the slope. 2079,33 newtons. You are expected to give a direction. Determine whether the quad bike will remain stationary or slide down the slope. Show your reasoning. So what I'm going to do is I'm now going to establish what is this downward force. I know what that upward force is. What is this downward force? So I say it's the opposite side, because obviously that line is equal to that over there. So we're going to say sine 30 degrees is equal to the parallel component of the weight divided by the weight, and therefore my parallel component becomes 1715 newtons down. Well, 1715 is less than 2079, so the maximum frictional static force is going to be greater than the downward force, and therefore it does not slide down the slope. Does not slide down. Last question of the physics paper. A 0,5 kilogram block is joined to a 0,3 kilogram block by means of a light string. The 0,3 kilogram block hangs vertically on the string, and it's passed over a frictionless pulley. A horizontal force of 6 Newton is applied to the 0.5 kilogram block, which slides along the horizontal surface as shown in the diagram below. So 6 newtons is bigger than 3 newtons, because remember this downward force over here would have been, it's not quite 3, it's 2,94, but 6 is bigger, so this system actually moves up and to the left. The 0,5 kilogram block experiences a frictional force of 2 newtons. That frictional force has to be against the motion. Calculate the magnitude of the acceleration of this system. So, first thing I'm going to do is I'm going to consider the force resultant on this block. Big force is 6, minus, there's a tension obviously acting over there, it's the same as that one, minus the tension and minus the frictional force, which we know is 2. I'm going to rearrange this. Tension is therefore equal to 4 minus, force resultant is always mass times acceleration. which is 0,5 times the acceleration of the system. Looking at the 0,3 kilogram block, we are going to do the following. Force resultant is equal to big force, which is the tension going up, minus the little force, which is the weight, which is 2,94. Force resultant is mass, 0,3. Acceleration of the system is equal to T minus 2,94. So tension becomes 0,3A plus 2,94. I then equate the two tensions because they are the same, and I land up with 4 minus 0,5A is equal to 0,3A plus 2,94. And when I rearrange that, A turns out to be 1,33 meters per second squared. Now if I need to calculate the tension in the string, I can take that acceleration, substitute it in either over there or over there, and either way when I substitute it, I find that the tension turns out to be equal to 3,34 newtons.